Suppose a charged particle having positive charge enters in an electric field. Here electric field is given by two plates. Upper plate positive charge, lower plate negative charge. Upper plate positive charge will repel the positive charge and lower negative plate will attract the negative charge. Here the path is parabolic. What will happen if the charged particles enter in a magnetic field? The answer is it will be either circular or helical depending upon the direction of the charge entering in the magnetic field. This is given by Lorentz force, and the Lorentz force is given by QVB sine theta, where Q is the charge, V is the velocity, B is the magnetic field, and multiplied by the sine of theta. Theta is the angle between velocity and the magnetic field. If theta is not equal to 90 degree, then the path is helical, and if theta is 90 degree, the path is circular. Why now this helical or circular? Because it is having a constant magnitude. Velocity is constant, charge is constant, magnetic field is constant. Then what is changing? The direction is changing. Direction of force is changing. At every point, it is experiencing a change in the direction, and that is the point. We can say that this follows a circular path. Means the answer is Lorentz force gives the idea about why the charged particle rotates in magnetic field. So now we can have two relations, F is equal to QE and QEB. One is for electric field, another is for the magnetic field. Let us calculate the force on a current carrying conductor placed in a uniform magnetic field. Let us say this is a magnetic field. North-south poles are there. A conductor of current carrying current I is placed in this magnetic field. It has length L. Suppose charge is moving in this and the current I is moving in it in a time t. Use the relation F is equal to QVB sine theta. So velocity is length upon time. What is the velocity? Length upon time. Whose length of time? The charged particle that covers distance L. We can say Q upon t here. We can replace time. So Q by T becomes time, current. So F is equal to ILB sine theta, or it is governed by the relation F is equal to IL cross B. Oh, it is very well known, Fleming's left-hand rule, where F is thumb, force represented by thumb, central finger represents current, and the first finger represents the magnetic field. You can stretch your three fingers in perpendicular direction. Let us discuss the torque on current carrying coil which is placed in magnetic field. Suppose this is a magnetic field, and let us say this is a rectangular coil having length L, breadth B. See, I have drawn two forces in opposite direction. On the left side, force is in downward direction, and on the right side, force is in upward direction. Why? Because of Fleming's left-hand rule. The current is in opposite direction, so force will be also in opposite direction. So here comes an idea of torque. Why? Because when two forces act on a body in opposite direction, the body will rotate. And when the body is rotating, there is a torque. And the torque is force multiplied by the perpendicular distance. What is the perpendicular distance? Perpendicular distance is its breadth. That is a B. So F into perpendicular distance gives the torque. Torque is ILB sine theta into B. So L into B is the area, so formula becomes tau is equal to IAB sine theta. Let us say N is the number of turns, then the magnetic field, then the torque will be multiplied by the N. So means tau is equal to NBAI sine theta, means torque will increase N times. If we want to have maximum torque, then what we will do? We will make sine theta 1. How you can make sine theta 1? By considering theta is equal to 90 degree. This can be only done by using radial magnetic field or curved poles or having a horseshoe magnet. By doing this, the area is always parallel to the magnetic field, or theta is always 90 degree. You can say torque maximum is NBAI. Let us discuss cyclotron. Cyclotron is an accelerator of charged particle. It can increase the kinetic energy. we require a large amount of kinetic energy to carry out nuclear reactions. It is based on the principle that if a positively charged particle to be accelerated, then there can be a very small amount of oscillating electric field and a strong magnetic field can be given to this charged particle. Of course, it has the principle of that time period is independent of velocity and radius, and of course synchronization. We will synchronize the oscillation of the charged particle, rotation of the charged particle with the time, means we will fix the time period. We will make it independent of radius and velocity. So consider the theory of cyclotron. We know the Lorentz force. The maximum Lorentz force is QBB because we have to use theta 90 degrees. So sine 90 is 1. Also, we know centripetal force is equal to F is equal to mv square by r because Lorentz force gives the circular motion. So there will be centripetal force also. And of course, the speed is 2 pi r by t. R is the radius of the path and v is the velocity. M is the mass of the charged particle. B is the magnetic field. So compare 1 and 2, you will get the velocity of v equal to qrb by m. Put the v is equal to 2 pi r by t, you will get the value of time period 2 pi m by qb. You can calculate the frequency or angular frequency of the charged particle. Here it is clear that time period is independent of velocity and radius. More be the velocity, more be the radius. Calculate the maximum radius, calculate the maximum velocity. You can calculate the maximum kinetic energy, that is equal to half mv square. Also consider half of the time period, t by 2 pi m by q b. Why half of the time period? Because in construction we have considered 2Ds. We have synchronized the charged particle, the motion of charged particle, that when it spends time t by 2 in 1D, and that will be the frequency set in high frequency oscillator. Consider 2Ds perpendicular to the magnetic field. These Ds are semicircular and hollow from inside. Connect high frequency oscillator to these 2Ds. And what happens? Now discuss first of all the construction. Consider strong magnetic field in which two semicircular Ds, D1, D2 are placed perpendicular to magnetic field. High frequency oscillator is applied to D1, D2. To change cycles, window W is given to carry out maximum kinetic energy, and the charged particle comes out of the target and strike on it. Working. When high frequency oscillator is switched on, the positive ion placed at the center of D starts moving. Suppose it's a positive cycle, D1 will get positive and D2 will get negative. So positive ion will be repelled towards D2 because D1 is positive. When it is repelled, definitely it is in a magnetic field. It will start rotating because of Lorentz force. And when it enters D2, it rotates there. And when it comes out from D2, the cycle changes. Now D2 will get positive and D1 will get negative. Here the positive charge on D will repel this positive ion which is leaving the D2. So this will give an repulsion to the charge. It will increase its radius and velocity. So here lies acceleration. So again and again the cycle changes. Again and again we are getting the maximum kinetic energy. On when it reaches to the largest orbit, it will get the maximum kinetic energy and it will hit to the target by having maximum kinetic energy. Or we can say that we have accelerated charged particle to a large extent. However, it has some limitations. If charge is 0, means it is neutron, then no force will act on it. So no electric field, no magnetic field. So it will not be accelerated. Secondly, we cannot accelerate electron because electron is having very small mass, 9.1 into 10 raised to power minus 31 kilogram, a very small mass. And if it has very small mass, then a relation can be applied, that is the relativistic mass theory, m is equal to m naught upon 1 minus v square by c square. This is for the particle which can acquire velocity equal to velocity of light. Electron can have a very large velocity because its mass is small. So it can have a velocity equal to 1 by 10th even also. So time period cannot be fixed. And if time period is not fixed, it will not be synchronized. If it is not synchronized, electron can collide in between the D's. So how it can skip out of it? So electron and neutron cannot be accelerated in cyclotron. Moving coil galvanometer, the instrument used to detect the flow of charge in a circuit, is called moving coil galvanometer. It is also called deadbeat galvanometer. Oh, it is based on the principle that when a current carrying coil is placed in magnetic field, it experiences a torque. We can have it's a theory that a torque is equal to, or it is directly proportional to, the deflection of the coil which is oscillating in the magnetic field. More be the deflection, more be the torques. Let us say K is a proportionality constant which is restoring torque per unit twist. Also we know that torque is equal to NBAI. So equation 1 and 2 are same, so we can get I is directly proportional to theta, or I is equal to K upon NBA theta, or K upon NBA is a G galvanometer constant, so I is equal to G theta. Let us discuss about its construction. We have to make a maximum torque. For that we have to use radial magnetic field by using horseshoe magnet. Here are two curved poles. Pole magnets are used having north south. In between them place a coil. That coil is wounded on a iron core that is represented by point C, that gives a maximum concentration of magnetic field in it. And also put it in a frame of bamboo. It is suspended vertically with the help of torsion head. You see here is a flat strip of phosphor bronze wire on which mirror M is suspended. On this mirror we have to give a light using lamp and scale arrangement. When this coil oscillates, then definitely it deflects, and if it deflects, that deflection is observed on the scale. Let us that deflection is theta. So more be the deflection, more be the current, as we have discussed in the theory that I is directly proportional to theta. So let us discuss its working. When a current is given to coil, it experiences a torque. The oscillation of coil gives deflection, which is deflected on scale, and after reflection of light from lamp, more deflection is observed, gives the value of current. Let us discuss the current sensitivity and voltage sensitivity. Current sensitivity means the deflection required per unit current, or voltage sensitivity means deflection required per unit voltage. For having more current sensitivity, small current, large deflection, or for more voltage sensitivity, less voltage, more deflection is to be observed. We know the relation theta by I is equal to NBA by K, and for voltage sensitivity theta by V is equal to IR, so NBA by KR. Keep in mind you cannot increase NBA, because if you increase number of turns, magnetic field or area, they will lead to the bulk, and in fact you can decrease the value of K and R. That's why you have used the phosphor bronze wire, a flat strip of phosphor bronze wire. Now convert this galvanometer into ammeter or voltmeter. What is ammeter? Ammeter is a device which measures current, and anything which has to measure current to be connected in series, and which is to be connected in series must have low resistance. And similarly for voltmeter, on the other hand, for voltmeter is the device which measures the potential difference. For measuring potential difference, it is to be connected in parallel. The condition is this, that it must have high resistance. So let us make ammeter and voltmeter, means conversion of galvanometer into ammeter. When you want to reduce the resistance, you have to put a very small amount of resistance in parallel of galvanometer. The parallel arrangement reduces the resistance. So lesser is the value of shunt, more is the current it can carry, it can measure. Ig is the maximum deflection that a galvanometer can have. But what happens if we have more value of current? Then we have connected a shunt. The remaining current I minus Ig passes through this shunt. The basic is that the potential difference across G must be equal to potential difference across S. So Gig must be equal to S into I minus Ig. I minus Ig, you can get the value of S, Gig upon I minus Ig. S is shunt, G is a galvanometer resistance, Ig is a full scale deflection, and I is the required range of the ammeter. If we want to convert galvanometer into ammeter, we have to increase the resistance. So put a resistance in series with the galvanometer. More be the resistance, more be the voltage we can measure. So here the basic theory is the potential is divided in G and R. So use the relation V is equal to Ig into G plus Ig into R. Find the value of R, that is V upon Ig minus G. So R is the resistance that is connected in the series of the galvanometer. Keep in mind, if S is reduced to a small extent, more current can be measured, and if R is increased, then more voltage can be measured. Let us discuss now the force between two parallel currents carrying currents between two straight wires which are held parallel to each other. Step 1, let us say I1 is the current from where I1 current is flowing in the wire at a distance R12. At a point P, find out the magnetic field. So magnetic field is calculated using Ampere's circular law. B1 is equal to mu naught I1 upon 2 pi R12. R12 unit cap. R1 unit cap is the direction of the force, and that is from 1 to point P. So place at this point P another current carrying wire I2. That's why I have considered R12. So it will experience a Lorentz force, that is F is equal to ILB sine theta. Let us say F upon L, that is force per unit length, is considered, and this force F21 is equal to I2B1. Put the value of B1, you will get the value here, and calculate the magnitude. F is equal to mu naught I1 I2 upon 2 pi R. Be clear that the force is towards the current I1. Now, if the same arrangement is repeated, means this time calculate the value of magnetic field due to current I2, then you will get the value of B2. Let us, the distance is same, R. The direction is different, R21, earlier it was R12. So B2 will be equal to mu naught upon 2 pi R21 I2 R21 unit cap. R21 is the direction of the unit vector. Now step 2, place a current carrying conductor I1 at Q. So it becomes the same as we have discussed in the earlier case. So again, find out the force F12 on it. This will be I1B2. Put the value of magnetic field, and in magnitude you will get mu naught I1 I2 upon 2 pi R. Keep in mind that F12 will be towards I2, means if the current is moving in the same direction, the force is towards each other, means they are attracting each other. And if R12 is equal to minus R21, this shows F21 is equal to minus F21. This obeys Coulomb's law also, or you can say this is attractive in nature. Let us define the SI unit of current. You know, it is a fundamental unit and it has unit of 1 ampere. Let us say F is mu naught upon 2 pi or 2 into 10 raised to power minus 7 Newton per meter. I1, I2 is equal to I, R is 1 meter. Then the current will be equal to 1 ampere. Use this relation. F is equal to mu naught I1, I2 upon 2 pi R. So definition is, if two parallel current carrying wires of infinite length, negligible cross-sectional area held at 1 meter parallel to each other, then they experience a force of 2 into 10 raised to power minus 7 Newton per meter. This current is said to be 1 ampere.